Chapter 8, this is linear regression. So we're getting full-fledged into our two-variable data analysis. Okay, in Chapter 7 we got into the beginning parts where we're going to be looking at just scatter plots and kind of what it meant to find a line of best fit, and then what we called this R value, which we called correlation or correlation coefficient, which describes two things. It describes the strength and the direction of my scatter plot, right? My line of best fit. It's going to be how closely the dots are to a line, and it's going to talk about the direction, whether it's a positive slope or a negative slope. In this chapter, we want to take that a step farther. We want to go into the deeper understandings, the deeper analysis of those kinds of things, and talk about how we can create lines of best fit, regression models based on data, and then how can we go about checking our analysis to make sure that we're doing a good job and bringing all of those checks and balances up to speed so that we can say that our analysis is a good thing. And so we're going to look at a few things. We have, in the past, we've looked at this data. We've talked about lines of best fit. We've talked about y-intercept. We've talked about slope. It's at this point we need to go ahead and give these things some actual formulas. So on the screen, in general, we say y hat. You can see that down here. This is a better rendition of the formulas. These are the actual formulas we're going to be looking at. This is my line of best fit, right at the top here. The B0, this is our y-intercept. Our B1 is considered our slope. And the bottom, you can see the actual formulas we're going to be working with. These formulas are actually on your formula sheet. You're going to forget they exist by the time we take this test. I'm telling you now so you can go in, make sure that you highlight them, circle them, underline them, do something of the nature so that you're going to remember that they're there. Here's what they are. Number one, or the first one you see is your y hat. The hat symbol indicates that you have an estimate. This is an estimated y value based on some x value that we have in our data. B0 is my y-intercept, B1 is my slope, just like we said earlier. Here are some formulas that allow me to get the slope and y-intercept when I don't have the actual data to put into the calculator to do lin reg, right? So if I have the standard deviation, if I have the averages, if I have my correlation coefficient, then I can find what R is from the data, and I can actually find my line of best fit without actually having to go through all the lines of best fit with the formulas. We can do it, or without using the calculator to do it, we can do it with just these formulas you see here. Okay, and so if we take a minute and look at these this is actually the Burger King data that we looked at earlier in the last chapter. Here, if we take a minute and we look at that line, but we've got an extra point, we've got a really high protein, low fat, so maybe this is a chicken sandwich or something, I don't know. And we put that line of best fit in, this is what happens. When a lot of us want to kind of ignore that point at the bottom. Every point matters, right? Everything that we try to do here, when we did it last time, we didn't look at every point. Every point didn't really matter to us, right? We looked at, just when we were looking at monopoly, we looked at the kind of like that big, huge line, that trend line that kind of looked at the center point, and we ignored the outliers. We didn't know if they mattered in terms of like, is it going to actually influence my line? And truth be told, every point will have some influence over my line of best fit. In this example, you can see exactly how we have all these scattered dots here, but this dot tends to pull the line down a little bit more, maybe so much more than we expected to. And so that brings us to kind of officially announce what kind of line are we going to be calculating. We've got things where we found median lines in the past. With the Monopoly Lab, we just kind of found a line of best fit through just 2 points. We had a lot more than just 2 points, so it was a big deal to actually do it in the right way. And so the line of best fit that we're going to study is called the least squares regression line. Let's talk about just some basic things here. And we've already done this, but let's just kind of go through it and review a little bit. We talk about slope and y-intercept. And putting these things in context is a really big deal, right? So for example, if my line of best fit is fat equals 6.8 plus 0.97 times protein, we want to be able to describe the slope in context. If we did that, we would say for each additional gram of protein, I would expect the fat grams to increase by approximately 0.97 grams. We can do that because that's what the slope is. We can see that in our equation down there in the bottom, right? And if you look at the y-intercept, 6.8, if we look at that in context, what we would say is that if we had a sandwich that had no fat, then we would expect, or sorry, if it had no protein, then we would expect there to be 6.8 grams of fat. The y-intercept, one more time, was if there's no protein, if there's no x coordinate or x variable, then there would be 6.8 grams of the y coordinate, y variable, which is fat, right? And here again, the hint is if you didn't use the words fat or protein, then you kind of missed the point of putting it in context. All right, for the first time, we have our assumptions and our conditions. In this example, or in this slide, we're going to talk about what's kind of required in the next couple slides. But, so residuals, in order for me to check my assumptions and conditions, I have to actually know what a residual is. If you were to tell me, well, if I had a data set that had basically, if I had the number of hours you spent studying for my last test and your grade on my test, could create a line of best fit. And basically, you could tell me how many hours you spent studying, and I could predict your grade, right? The amount, because when I predict, it's not 100% certain, right? In fact, it's probably a pretty big range. I could be off by a little bit. If I predicted that you were going to get a 90 on my test, but you ended up getting a 95, then I would have underestimated your grade, right? The residual there would have been observed 95 minus the predicted 90. It would have been a positive 5. If you had gotten an 85 when I predicted you were 95, then I overestimated your value, right? You would have had 85 minus my 95 to get negative 5, right? I overestimated it, so my residual was negative. A residual plot is one of the ways that we're going to be able to check our assumptions and conditions. We'll talk about residual plots in a different video, but note that they're just a scatter plot using specific lists for x and y. What we want to see in a residual plot is that there's no pattern at all, right? If it's just a big random scattering of dots in that scatter plot and it passes that nearly normal or straight enough condition. Not nearly normal, straight enough. That's another thing, right? So here, let's look at a few of these. Here's a residual plot that has a pattern. That's curved. We're doing linear regression. That's bad. That fails, right? That's a deal breaker. If that's the case, then you're game over, right? No more linear regression. Here we have a residual plot that shows a random scattering of dots. There's no pattern at all, right? It's just a big blob of dots. You've got your line kind of going through the middle of those. That's what you want to see. That's when it passes it. There's another condition, okay? The last two pictures here demonstrate the plot. It's called the equivariances assumption or equivariances condition. In this case, what we want to make sure is we want to have the variance, the standard deviation, kind of the same throughout my line. I don't want it to be like this kind of funnel shape, right? You can see that right here in the blue or the red. You can see how it's really close. So in the first half of that section, when I go to predict, I'm going to be pretty accurate. My R value would be really strong, right, in that case. But as I move down my line, my pattern widens and my R value isn't consistent throughout, right? Although if I did lin reg, my R would get a specific value. But when you see this pattern, it's telling you there's going to be a problem, that you're going to be really accurate when you predict with certain data, and you're going to be really off with other data. So your book calls this, I think, does the plot thicken condition, right? That's a lot to say. So equivariances assumption is probably a lot easier. But this is what happens. When this happens, this is not good. It's not necessarily as bad as the other one, as this one is with the curved pattern. But this is something I'm going to comment on. I'm going to say, because there is a pattern, a ramp or a kind of a funnel pattern happening in the residual plot, the equivariance is not okay. And I may have an issue when I go to predict, right? I just need to comment on that kind of thing. All right, and I mentioned this earlier in Chapter 7. R squared, by name, is called a coefficient determination. This is not in your book, but it shows up on AP tests and my tests, so make sure that you write the name down. Remember, R is correlation coefficient. R squared is the coefficient of determination. Know the differences. What you want to walk away from this with is there's a script that I need to I need to memorize. I need to know how to say it. And it's the percentage of variation in Y that can be explained by the variation in X. Let's go back to the data where I talked about, I had your number of hours studied and your grade on the test. So I could say, let's say that my R squared was, and we always talk about it as a percentage. Let's say R squared is like 0.75. So that would be 75% of the variation in the test scores can be explained by the variation in the number of hours spent studying, right? So generically, what you want to say is that it's the R squared percent of the variation in the, let me start over. R squared percent of the variation in the Y variable can be explained by the variation in the X variable. So those R squared, X variable, Y variable, those are kind of like fill in the blanks. I would write that down and kind of learn that script. So whenever you are asked, hey, what is the percentage of variation? Oh, that's talking about R squared, right? Keep that in mind. It's in your book a couple of times, right? Check that out. It's really simple. It's just something you got to kind of remember and keep in mind of what that means. Okay? In your book, I can't remember the page number, but it is at the end of chapter 8, right before when the question part starts, right before the book problems start, right? This is super important, right? What's in that red kind of rounded rectangle you see here, I'm not going to need to know that stuff right now. Later on, yes, but not right now. So the rest of that stuff where you see the coefficient and you see constant or 10.584 and the DHL, and that's the actual variable name. I don't even know what this is, but what I see here is that I need to know what these are. Your constant, the row where it says coefficient constant, where those things meet up, that's your slope. Or your y-intercept, excuse me. The top one is the y-intercept, the bottom one is your slope. So 0.5632, that's slope. The other things I want to make sure to look for, sometimes your line of best fit equation is written right there, okay? In S, that's the standard deviation of the residuals. That's kind of how far off of my line are the points going to be on average. This is a lot like standard deviation that we're used to. R squared, the 60.8%, that's something I want to pay attention to. R squared adjusted, ignore that. Don't ever look at that, right? And the standard deviation, the t-ratio, the p-value, we'll get to those in due time, but that'll be next semester. Make sure you know what that is. The book, in your book, it's got all these labels around it. Make sure I put that in my notes. Go check it out and come from there, right? Okay. So these are the things that you want to make sure to label it down. So if you don't have that, take a screenshot. Make sure you can label that on your notes. Okay, it's in your book. It's at the end of chapter 8. All right, let's move on. And actually, that's it, right? So homework tonight is just going to be looking at your book problems from chapter 8. It's a big deal. Chapter 8 is kind of where we're going to build a lot of our knowledge on this stuff. This is the biggest chunk of our next test, right? So definitely put your time and effort into that. I hope this really helped out. Obviously, you can watch this as many times as you want to. If you got any questions, please bring them to class or send me a message. And no joke about that. A lot of you guys don't really communicate very well. And if you're getting the material and you're doing a great job, I don't have any problem with that. That is fantastic. Apparently what I'm doing is enough to get you a good grade on the test. But if you're struggling, I'm here for you anytime you need me to be, right? Email me. You can request a Google Meet session if you want to, right? So just kind of let me know and I can reach out and we can try to get some of this stuff down. Anyway, I'll see you guys